Good morning, students. In the previous video session, you have gone through the properties of scalar product and about the scalar product. And today we are going to discuss about a vector product and its properties. First thing, what is meant by this vector product of two vectors? Assume that you have two vectors. Assume that you have two vectors like this, vector A, one is going this direction and another vector this direction, B vector. If you are taking the magnitude of these two vector, we will get another vector, C vector. You see, here you can see two vector, A vector and B vector. One vector is in one direction, another vector is in another direction. So this is A vector, this is B vector. So the resultant of these two vector will be another vector which is called C vector. So if we are taking the resultant of this, we will get a C vector is equal to A vector cross B vector. And this is what we called as cross product or vector product. The same formula you can write in terms of only magnitude A, B, sin theta. C is equal to. So C is equal to AB sin theta. This is only magnitude, and here you can see there is a direction. Vector notation is there. That is what we have wrote this equation. C vector is equal to A vector cross B vector. But without these directions, we can write this equation only C is equal to AB sin theta. And this is what we can tell vector product of two vectors. Now let us see this definition. Vector product or cross product of two vectors is defined as another vector having a magnitude equal to the product of the magnitude of two vectors and the sine of the angle between them. This is what I explained here also. Vector product or cross product. This is what the vector product or cross product A cross B, or you can tell A vector cross B vector. So this A cross B is what the product of these two vector. We can define by using what and another vector which is called C vector, which is equal to what which is equal to this vector product or cross product of these two vectors. We can indicate by using another vector C vector, and this C vector we can define as what C vector is equal to A cross B. So this A cross B means what product of this A and B. So that is what product of these two vectors and sine of the angle between them, sin theta. This is how you can define a vector product. The vector product or cross product of two vector is defined. How you can define? It is the product of, it is what the product of the magnitude of these two vector and the sine of the angle between them. So from this formula you can write this definition of vector product of two vectors. So vector product or cross product of two vector is defined as the magnitude equal to the, this one magnitude is equal to, maybe if you are giving some value, some 5 is the value here. So 5 means if you are taking, or 15 is the resultant magnitude, and A is 5, B is 3. If you are taking 5 cross 3, 5 into 3, what you will get? 15. That is what the magnitude equal to the product of these two vectors and the sine of the angle between. So this is what the definition. And to know the direction of these three vector, you can see A is in one direction, B is in another direction. So the resultant C is in, apart from these two direction. This we can indicate by using a right hand rule like this. Hold your hand like this. This is what a right hand rule. You can fold your fingers. This curvature of these fingers, this sense of rotation, no? And this one represent the sense of rotation of the object, and this thumb, when you assume that you are holding the pen in your hand like this, and this you are holding this object by use your finger, and this is the sense of rotation of the object, then this thumb held, this thumb is what? This thumb is perpendicular to the curvature of these fingers. You can see that this finger is moving this direction, but thumb shows opposite direction. So these two are mutually perpendicular. Perpendicular means what? 90 degree to each other. That is what in definition you can write. So this direction of this product vector, if you are taking this finger rule, and this thumb shows the resultant vector C vector. So this C vector is equal to A cross B. So the direction of the product vector is always perpendicular to the plane containing the two vectors. You can see this rule here, thumb rule, you see. You can write C is equal to A cross B. You cannot write if you are keeping opposite, what will come? Minus C is equal to B cross A, or you can write what? C is equal to minus B cross A. So this is what vector product, about the vector product. Next you can see the properties of vector product. First property, this is also one of the important question. The vector product of any two vector is always another vector whose direction is perpendicular to the plane containing these two vectors. So already I told if three vectors are there like this, this is A, this is B, means then C is what? This is what? The vector product. C is the vector product, and this vector product of what? Vector product of any two vector. Any two vector you take, A, B, take. So this AB vector product is always what? Always this one direction is perpendicular to these two vector. So that's what before I told, by using the finger rule, C is always perpendicular to another two, A and B. So C is always perpendicular. Here in words you can tell the vector product of any two vector is always what? Another vector whose direction is perpendicular to the plane containing these two vector. Always this two vector is what? And this is perpendicular to each other. Or you can tell that orthogonal to both vectors. The C is always orthogonal to this A and B. So that is what the first property. The vector product of any two vector is always another vector whose direction is perpendicular to the plane containing these two vector. So you can write this A cross B is equal to what? C. This is what you can see the diagram. C is perpendicular to this A and B. And the second one is the vector product of two vector is not commutative. So this one is not following commutative property. We know that commutative property means what? A cross B is equal to B cross A. In scalar product you have learned dot product is commutative. A dot B is equal to B dot A you have learned. But here not equal. Here what? A cross B is not equal to B cross A, but you can write this what? You have to mention always this vector symbol above this. But you can write this A cross B is equal to minus B cross A, you can write. Okay. So what is second property? What is second property? The vector product of two vector is not commutative. That is what? A cross B is not equal to B cross A, but you can write A cross B is equal to minus B cross A. So this is what you can write in magnitude. A cross B is equal to, this is what only magnitude we are writing. Magnitude means no need of any symbol, minus symbol. A, B, magnitude of B cross A is what? Equal only, no? Suppose A cross B, 3 into 5. 3 into 5 is 15. The same what will happen? Same what will happen? 5 into 3 also 15 only, no? Suppose A is 3, B is 5, then 3 into 5 is 15 only. Here B is what? 5 and A is 3. Now also we will get 15 only. So the magnitude of A cross B is equal to what? B cross A. That is what? Second property. Now you can see the third property. The vector product of two vectors will have maximum magnitude when sin theta equal to 1. Theta value is 90 degree. So if we are taking this vector product, what will happen means we know that C is equal to A B sin theta. So the vector product of these two vectors will have maximum value. When this will get a maximum value, when this vector product will get a maximum value means theta will be 90 degree. Theta will be 90 degree means for this one, this A and B are 90 degree means what you will get? Sin theta equal to what you will get? 1. How you will get? Sin 90 means what? 1. So sin 90 means 1 means what you will get? AB into 1. So A, B will get. So what we will get? A cross B maximum. A cross B is maximum when sin theta is equal to 90 degree. You can see here A cross B is equal to AB sin theta. AB sin 90. Sin 90 means what? 1. So AB into 1. So AB will get 2. That is what? Maximum. So the vector product of two vectors will have maximum magnitude when theta is equal to 90 degree. Next one is vector product of two non-zero vectors will have minimum when theta. So the same thing only. Here the problem is if theta is equal to, suppose theta is equal to 0 degree or theta is equal to 180 degree. Then what we will get? A cross B, what we will get? A cross B will get a minimum. Why we will get A cross B minimum means we know that A cross B only we are writing what? AB sin theta. So if theta is 0, suppose first one, theta is equal to 0 degree. Theta is 0 degree means AB sin 0. We know that sin 0 equal to 0. So AB into 0 is equal to 0. So A cross B we will get what? Minimum. Another thing, second thing also what we will get? The same thing only. So A cross B we will get a minimum. You can substitute the values. So we will get what? Minimum. That is what? The third one. A cross B is equal to AB sin theta. So if AB sin theta or 180 we are putting means what? 0 will be the value. So the vector product of two non-zero vectors will be minimum and sin theta is equal to 0 degree. Theta is equal to 0 degree or 190 degree. Then fifth property. The self-cross product of a vector with itself is a null vector. A cross A is equal to what? 0. A cross A is equal to 0, but you have seen that in the scalar product A dot A is equal to, you have seen 1, but here just opposite, the self-cross product. A cross A means 0 we will get. Next one is sixth point. The self-vector product of unit vectors are 0. So what is fifth point? The self-vector product of unit vectors are 0. So we know that A cross A we can see that 0. So here we can write that is the sixth point. I unit vector cross I unit vector is equal to 0. J unit vector cross J unit vector is equal to 0. K unit vector cross K unit vector is equal to 0. That is what here it is given. I cross I unit vector equal to J cross J unit vector equal to K cross K unit vector equal to 0. And the next point is, in the case of orthogonal unit vector ijk in accordance with the right hand screw rule, so that you can write you see orthogonal, this 90 degree, 90 degree, 90 degree. So I vector, J vector and K vector, these three are 90 degree to each other. That is what we are saying orthogonal. So what we can write means I cross J. When you are taking these two, K is equal to, now you can see, I will show you. So like this. J I J K. Suppose if you are taking K vector, K unit vector we are taking means, K unit vector we can taking means I unit vector cross J unit vector. You see, if you are closing one, another two. If you are closing I, then what you can see? So I unit vector is equal to K cross J or J unit vector cross K unit vector. If you are taking J, then what you can take? J unit vector is equal to K unit vector cross I unit vector. That is what this point. In the case of orthogonal, I cross j is equal to k, j cross k is equal to I, k cross I is equal to j. Then what? If it is opposite, here I cross j we have taken k. So j cross I means we can take what? Minus k. Here j cross k we have taken I. K cross j means we can take minus I. Here k cross I is j. So if you are taking opposite, I cross k is minus j. Now you see this one in terms of component. The vector product of two vectors A and B is A cross B. How it can write? Suppose if you are taking like this, see A cross B is equal to I unit vector, J unit vector, K unit vector, AX, AY, AZ, BX, BY, BZ. Then A cross B, what we will get? A cross B will get you see A cross B is equal to, first you take I. When you are taking I, this 4 value you take cross product. When you are taking I, now AZ, AY, BY, BZ. When you are taking I, this 4 cross product you take. So I unit vector into AY, BZ, AY, BZ minus AZ, BY. Then here plus J unit vector. When you are taking J, you have to take this one, this one, this one and this one. Now you see AZ, BX, AZ, BX minus AX, BZ, AX, BZ. Again plus K unit vector. You can write what? When you are taking this K, this 4 on this 4 cross product. So AX, BY, AY, BX. So AX, BY minus AY, BX. This is how you can write for component vectors. That is what another point. Then ninth point is, if two vectors are A and B form adjacent side in a parallelogram. If it is like a parallelogram, then what? A cross B. This A cross B will give what? The area of this given parallelogram. So if these two vectors A and B forming adjacent side, these two side, now it is what? Two adjacent sides in a parallelogram. So that the magnitude of A cross B you can write what? AB sin theta. That is what? That is equal to the area of this parallelogram. So we can find out the area of the parallelogram also by using this concept. Now you see the last one. If you are dividing this parallelogram into 2, then what? Dividing into half, we will get like this. So A cross B divided by 2, so that you can write 1 by 2 A cross B. So these are the properties of vector product. You can take a screenshot of this, or I will send in your group also. You can study this in the same manner. In this same manner, you can solve example 2.9. It is very important 3-mark problem. Example 2.9. Very important 3-mark problem. You can follow the same method. Okay, and all of you study this. It is very important question. See you all. Bye bye. Thank you.